Hello my dear viewers. For today's video, we will be able to know what it's all about the modern periodic table of elements. Are you ready? Let's go! The periodic table is also known as the modern periodic table of elements. This is a tabular display of chemical elements, and this is widely used in chemistry, physics, and other fields of science. It is a matter that basically occupies space and has the smallest unit called atoms. In our periodic table, it composed of 92 kinds of atoms. One good example is what you call the gold. Gold has an atomic number of 79. It composed of 79 protons and electrons. In our periodic table, it composed of different elements. Element is a substance that made up of only one kind of atom, meaning to say, each element performs different characteristics. Almost 80% of the periodic table is composed of metals, 15% of the elements are non-metals, and the remaining elements are metalloids, which are properties of both metals and non-metals. Remember, Dmitry Mendeleev is considered as the father of modern periodic table of elements. If we have 92 kinds of atoms, definitely we have 92 kinds of different elements. As you can see here on your screen, it composed of carbon, iron, aluminum, astatine, ytterbium, oxygen, chlorine, bismuth, palladium, nitrogen, chlorine, zirconium, asthenium, tin, argon, copper, silver, sulfur, potassium, nickel, phosphorus, chromium, copper, lithium, titanium, uranium, hydrogen, lead, mercury, and bismuth, and so on and so forth. Hydrogen is the lightest element. It symbolizes capital letter H and has atomic number 1. Let's get more deeper about the modern periodic table of elements. The periodic table continuously evolved with the progress of science. It composed of rows that called periods and columns known as groups. As you can see, we have there group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 until 18. Elements from the same group of the periodic table showed similar characteristics of chemical elements. Group also representing the valence electrons as well as the family of each element. The table is divided into 4 rectangular areas known blocks, or also known as subshell. We have the S, P, D, and F. The first group is also known as alkali metals. The second group is alkaline earth metals. The 17th group known as halogens, and the last group known as noble gases. Remember, each group shows similar chemical characteristics of each element. If we have 7 rows, therefore we have 7 periods. Periods also representing as the energy level of each element. Let's say for example, we're looking for zinc. Therefore, zinc is belong to period 4 and has a group number 12. Another example, we're looking for calcium. Therefore, calcium is belong to group number 2 and period 4. Another thing, sulfur. Sulfur is belong to period 3 and group 16. Let's say for example, period 5. The elements as you can see on your screen are belong to period 5, like strontium, tin, and iodine. Again, we have 7 rows or 7 periods that shows the energy level of each element. Let's say for example, chlorine. Chlorine is belong to 17th group. And the elements belong to 15th group are nitrogen, phosphorus, arsenic, antimony, bismuth, and so on and so forth. Arsenic has an intermediate properties of metals and non-metals, known as metalloids. If you're looking for an element that having period 5 and group 2, that is known as strontium. That's it. That's the simple way for you to identify the periods, the groups of a certain element, and different characteristics of it. Elements can be classified as metals, non-metals, or metalloids. As you can see here on your screen, on the left side are those metals and on the right sides are those non-metals. Metals are good conductors of heat and electricity, and they are all malleable. As you can see on your screen, those are the elements that belong to metals. Let's name it. We have the gold, silver, iron, chromium, and aluminum. Most of the metals are solid at room temperature, which has a characteristic of silvery shine, except for mercury, which is liquid. Iron is a good conductor of electricity, such as gold, silver, chromium, and tin. Now let's proceed to nonmetals. Carbon, phosphorus, sulfur, selenium, and iodine are nonmetals because they have poor conductors of heat and electricity and not malleable or ductile. Many of elemental or nonmetals are gases at room temperature, while others are liquid and solid that has a property of brittleness. And now let me test you about the classification of each element. You are about to identify whether it is metals, nonmetals, or metalloids. Let's say for example, we have there osmium. It has 76 atomic number and located at the left part of the periodic table, so that's why it's a metal. Another example is iodine. It has the atomic number of 53 and located at the right part, so therefore this is a non-metal. Basic, di ba? Sige, medyo hirapan natin. Let's say for example, we're looking for yttrium that having the atomic number of 39. So therefore, it is a metal. Malleable and yet shiny. Another example is phosphorus that having the atomic number of 15. It is located at the right side, so therefore, this is a non-metal. This is not malleable and ductile and won't conduct. And how about the metalloids? The intermediate properties that they are more likely non-metals, but under certain circumstances, several of them can be made to conduct electricity and known as semiconductors that are extremely important in computers and other electronic devices. So as you can see, it has the properties of metals, and this is known as semiconductor that are extremely important in the properties of metalloids. On many periodic tables, a jagged black line as you can see on your screen are known as semi-metals or metalloids. Not all of the elements on the left side of your periodic table are metals. Like for example, hydrogen, known as the lightest element, it is colorless, odorless, and tasteless. Hydrogen is the most abundant chemical substances in the universe, constituting roughly 75% of a normal matter. Most of the hydrogen on Earth exists in molecular forms such as water and other organic compounds. As you can see on your periodic table, hydrogen is separately and located at the middle part of your periodic table. Hydrogen is non-metallic except at extremely high pressure and readily forms in a single covalent bond with most non-metallic elements, forming compounds such as water and nearly all organic compounds. In December 2016, 4 new elements were added to the periodic table. We have the nihonium, moscovium, tensine, and oganesson. Remember that Mendeleev is best remembered for formulating the periodic law and creating far-sighted version of the periodic table of elements. Scientists have confirmed the existence of 118 different elements. That is all about the modern periodic table of elements. I hope that you learned from this video. Until next time, goodbye!